construction will follow, safety always, zero harm, safety all the time. I can't even think of them all, but this was very different. So at South 32, our mindset around safety is our safety guarantee, which is we all go home, we all guarantee everyone will go home safe and well. Just seeing what kind of reaction I get in the mining world to guarantee. It's a troublesome word for some people in our setting. I can't really guarantee. That's the point. It's meant to be provocative, it's meant to be bold, and I love that. So it starts there, clearly. How do we deliver on our safety guarantee? How do we secure a social license to operate? How did we deliver on that purpose in this setting? What does improving people's lives now and for generations to come look like at Hermosa in southern Arizona? Obviously, we have to develop an asset that creates shareholder value. And how do we do that in a timely manner? We've all heard the horror stories, 27 years from discovery to first production. You know, things stuck in permitting for 10 to 15 years. So how do we do that different? And then lastly, there was a higher purpose for country. These are two very problematic supply chains when we think about zinc and manganese. And so onshoring critical mineral supply chains to reduce national security risk is absolutely part of it. And that's an element we had to dial up because to some stakeholders, that part is really important. And we all should obviously think about those risks. So that's what we hope to achieve. So starting in the first area, I want to step through each area, and I'm going to start with the sustainability piece. I talked about societal expectations raising and increasing. Just going out and getting your permits is not good enough any longer. I have a personal view, we need to probably stop blaming permitting processes and get on with doing some things differently that present something different to stakeholders and regulators. And so that's what we started to get to work to do. We identified a few areas where we knew we had to do some things differently from a sustainability standpoint. Water use, biodiversity, emissions, and how we manage tailings. A little bit of a career story about this part of it because this is the part that I really do enjoy a lot. And part of the lessons, I suppose, for those moving into the industry here are about maybe taking some chances in your career and taking a little bit of a different path from time to time to learn as much as you can about the industry. About 4 years into my career, I had a great opportunity to move with BHP to one of our Australian operations in Queensland and take on a tech services manager role for one of our largest operations. It was awesome. I got a chance to do large brownfield capital projects. I got to lead in a different cultural environment with different people that worked in a different way, which is really important. And so spent 5 years there. We did a lot of great things, business transformation, cultural change. I learned a lot. But when I moved back to the US after that, I was presented with a different kind of opportunity that I really wasn't sure about. It was kind of a fork in the road. And I didn't know at the time, but I'm really glad I made the decision I did. I was asked to lead the environment permitting team for that business. And I started talking to some of my friends about it, some of the other mining engineers, and they thought I was crazy for considering this. And I remember, this is a long time ago. This probably wouldn't be as unusual today, but back then it was a bit of a crazy move. It was a group that had really strong technical experts, very capable group, but they were having troubles with relationships with stakeholders, compliance, getting permit revisions approved. So I decided to do it. Why is this story important? It was a really great opportunity to lead in an area where I had no subject matter expertise. And that was a really important lesson because leadership is something different altogether. It's a different skill. And so all I could do is focus on leading and supporting this team of experts to do better work. I couldn't really contribute subject matter expertise to what they did every day. But what it did afford me the opportunity is to learn a lot from them. And that's the other, I think, real lesson here is you never stop learning. I learn things every day from the people I work with, and that never stops. And I think as I reflect, if I hadn't chosen to do that, and we did some great things in about 3 or 4 years in that role, and I learned a lot about building relationships with stakeholders, the environmental side of our business, what good looks like. I don't know how I would do my job well today. I don't know how I would have done my last job very well and the one before that. And so there are a few moments in my career where I moved sideways and went to do something very different that at the time seemed like a little bit of a risk, but are really critical for me to have any success in what I do today. So as we moved into the environmental piece of looking at what we wanted to do different, I'm gonna start with tailings, and I'm gonna tell a little bit of a story. When our CEO came to talk to me about the opportunity to take over and lead Hermosa, I mentioned I was in Melbourne, and at the time, I was the Group Health Safety and Environment Officer for BHP. I had accountability for health, safety, environment globally. I moved into that role 5 weeks after the Samarco tailings disaster occurred. So why is that relevant to BHP in that role? BHP was a part owner of Samarco, an iron ore mine in Brazil. We weren't the majority owner, we didn't operate the mine, but we had an ownership stake. If you're not familiar with Samarco, it's an iron ore mine, as I said, and in 2015, they had a seismic event, static liquefaction event on the left side of the dam, and 60 million cubic yards of material flowed 400 miles down the Ruidoso River, destroyed several villages, killed 19.
I'm sorry to interrupt, but you have some fantastic photography. Would it be possible to turn off the first couple rows of lights? We can see a lot better. Is that all right?
We'll check into it, but keep talking, please.
So, tailings flowed 400 miles down the Ruidoso River, killed 19 people, and the tailings eventually reached the Atlantic Ocean. It was the most confronting and tragic thing. Obviously, I came into this role 5 weeks and had no idea I'd have to get involved in something like that. So how is that relevant to the story? So I think a few things. We weren't the owner of the project, but our CEO stepped up and took accountability as if as if we were. And that taught me a lot about crisis leadership, but we also decided to investigate and follow up on the incident as if we were the owner. So we commissioned an independent expert technical panel to do a technical investigation led by Dr. Norbert Morgenstern and 3 other global leaders in that space. And then I was tasked with our chief legal officer to take those technical lessons and develop organizational lessons, roll those out within our company globally and to the industry, and just make changes in how we manage tailings. That was a seminal moment for me in really understanding what's important around leadership in the management of the catastrophic risks we do manage in mining. And it was extremely confronting to see what can happen when it really goes wrong. So again, how does that relate to Hermosa? So through those technical lessons, one of the things that had come out is where possible, and you can't do this in every setting, where possible, using dry stack tailings placement is one opportunity we have in an industry to eliminate or nearly eliminate liquefaction risk. So one of the first things we did at Hermosa when we got onto the site in 2018, 2019, there's a lot of historic mining in the Patagonia Mountains, a lot of tailings placed everywhere, a lot of environmental legacy issues. We entered into a voluntary remediation project with the Arizona Department of Environmental Quality and cleaned up about 2 million tons of tailings and built a new first of its kind dry stack tailings facility. It was the first start, and the way I refer to that step is we were kind of closing the book on mining of the past, fixing an issue and demonstrating what next generation mining could look like from a tailings management standpoint. And it was a great collaborative effort with ADEQ, so thank you to Ms. Sayo Cabrera, who's here, who was the director at the time. We appreciate the collaboration. It was a really good project. So we built a dry stack tailings facility. One of the things about the technology and approach we've taken at Hermosa is not everything we're doing is leading edge, cutting edge technology. A few things are, and I'll highlight those, but a lot of what we've done is just convergence of various best practices, approaches, and technologies that might be used in different places and brought it together in one place for the first time. So if you look at a lot of what we're doing, this part might be done at mine A, this part might be done at mine B, this mine C might be trying this part, but when you bring some of these together, you can get a very different outcome. And so if we think about some of these also contributing to multiple goals, and in some cases we had to do different multiple goals, multiple objectives to deliver on something. And so in this case, dry stack tailings, obviously, to create a safer, more stable tailings management system. But also, I mentioned one of our other focus areas was water. Obviously, I don't need to share with you the importance of that in this setting. We also, with the design of the dry stack tailings facility, are able to recycle about 90% of our processed water. So we have a tailings filtration plant on the back end of the plant that allows us to recover that water, recycle it, and reuse it. So Hermosa will use about 90% less water than a typical mining operation. The base metals mines we see around the US use between 5 to 10 gallons of water for every pound of metal they produce. We'll use 0.6 because we're able to recycle and reuse water. So new design, improved tailing safety, and in the process of that, create a very different water consumption, water use, water efficiency profile. The other thing dry stack tailings does is it helps us at closure. It's easier to do contemporaneous reclamation. You can do closure in a way where you don't have perpetual water treatment, and it also reduces our surface disturbance footprint, which is the next area I want to talk about. Biodiversity. How many of you have been to the Patagonia Mountain region and hiked and camped? It's an area very rich in biodiversity. There's 200 plus bird species, thriving ecotourism business, renowned bird watching area. That's our setting. South 32 also has a goal of no net loss of biodiversity in our operations, and we decided to make Hermosa the test case for how you achieve that, and more importantly, how you verify that through third-party verification means. And so it is an area where it warranted a very different approach, because biodiversity is important to the people of the community. Again, back to people. And so the two things we said we wanted to do: understand the biological landscape so we can avoid impact on sensitive species, and how do we make this the smallest footprint, smallest disturbance mine possible? How do we bring multiple approaches together to accomplish that? And so every mine in the world has to go out and collect biological information to do permitting, sensitive species, threatened and endangered species. But when do you do it and what do you use it for? Before the pre-feasibility study, we had collected a decade of biological baseline information for the project. It's typically used for permitting. We used it to make sure we laid out a mine that would not have any impact on sensitive species. We redesigned and moved our second tailings facility to avoid impacts on sensitive species. So don't just build it where the design makes the most sense, but how do we design to avoid impacts in the first place? This is the mindset. Safety and design that we talk about from a safety standpoint. How do we apply that to other things? How do we apply it to biodiversity? How do we apply it to cultural resources? So what did we get from that? The other technologies and approaches we've applied to address this: it's a long hole open stope mine, very large mine. We decided to go with cemented paste backfill underground. What does that do? Half of the tailings you would need to store on the surface go back underground to backfill the areas you've mined, so it reduces surface disturbance and surface footprint. We also don't have open pits. With backfill, we don't get subsidence features like you do from block caving. And then on top of that, dry stack tailings further reduces your footprint. So again, what else can we do? How do we stack technologies to get a different outcome, or stack different approaches? Process plant design even. So Jameson cells, it's a high intensity froth flotation cell that's used in the secondary part of flotation circuits in many base metals plants. Our plant's designed to be all Jameson cells. Why is that important? It uses 40% less space. So tailings design, underground mine design, process plant design, all to give us a smaller surface footprint. 70 years of mining, both the manganese and the zinc deposit will only disturb 750 acres of land, 400 of which was disturbed by historic mining, 350 acres of disturbance for 70 years of mining. Put that into context, the open pit mines we have around the region are 10 to 20,000 acres, some of as much as 40,000 acres. Even some of the underground projects that are out there are 7 to 8,000 acres. How do we present something different to stakeholders that converges or diverges from what they have in mind about what mines look like and how much space they take up and what impacts they have? So that was an important part. Emissions. South 32 has a goal of net zero greenhouse gas emissions by 2050. What's important about Hermosa? Most of these products that we produce are going to go into decarbonization. We don't want to build a mine that's going to further add to climate change when the mine's meant to be part of the solution to climate change. So we've developed a path for how we get to a net zero mining operation. It starts with power. So we have a goal of powering the mine with all renewable energy. We've been working with our utility partners, TEP and others, for how we do that. It's likely to result in some additional solar development and some benefits beyond just the mine needs. How do we eliminate the use of diesel fuel? Well, let's start underground. So obviously these mines of this scale will produce a little over 4.3 million tons a year out of the underground mine. It's a pretty big open stope mine, probably one of the top 10 at that scale. When we started the pre-feasibility study, you could not get battery electric equipment and all the types of equipment we needed for a mine of that scale. But to show you how quickly times have changed, how quickly this technology is accelerating, earlier this year we placed the largest order of battery electric equipment in the history of the mining industry. By the time we're at full production, it will be an all battery electric equipment underground fleet, both the primary production equipment and the support equipment. And so that's how quickly it moves. So clearly that's a big step forward. We're also working to try to go to battery electric fleets in our surface transportation. And we do believe we can get to net zero fairly early in the life of the operation. So I talked about individual solutions solving multiple goals. What else does battery electric equipment do for us? Well, if you've ever driven an electric car, they accelerate pretty well, don't they? So battery electric fleets, particularly in the mucking cycle faster. There's productivity benefits. They have less moving parts. There's maintenance benefits. It changes how you ventilate the mine and improves the ventilation scenarios. The other thing they do is it reduces noise, and I spent a lot of time in my last role doing HSE work for BHP, figuring out how we address the risk of diesel particulate emissions underground in mines. Well, we've eliminated that risk in design. And so this mindset around reducing our footprint in design is a lot like how we engineer hazards and risks out of the mine. So we think about safety in design. How do we think about reducing our impact on biodiversity in design? How do we think about reducing the risk of liquefaction events and tailings in design? And there's more of that to come. So this is probably the mindset that's a little bit of a shift for us, is realizing that in our engineering and design work, we can have an impact on all these things. We can make decisions that give us a different profile. Maybe not do all of it in every setting, but it's really about having that mindset from the start, really early in the project, and thinking about how you utilize that information. So why is this important? Well, it's really important to get things permitted, obviously, but it's also really important for our stakeholders. Again, back to people. And that leads to my next discussion. So with that total environmental